Hey everybody, it doesn't happen very often, but we're going to restore this beautiful old 1952 Tsugami grinder. Now this old machine, you might wonder why anybody would ever want to recycle something like this, but this one is specifically fits our needs for the size of swing and length of shaft work we're intending to do. And usually this is about the cost. It's a journey to restore an old piece of equipment, but you do it because you have a need, and because the cost of new machines is really high. You don't want to take on any debt. And it looks like in this case, just by looking at the machine, it looks like it's complete. It doesn't look like an overly complicated piece of machinery. Grinders typically aren't. And when you look at what this costs out of the gate compared to a new one, we're at least 1/10 of the cost of a new machine that would have similar capabilities. These can get really expensive. Also, I'm fortunate enough to have my own truck, access to trailers, so if you can find something local, transport it yourself, you can really keep the cost down. So it is about the economics, it's about the cost, it's about what else you might be able to use your time with. But what does used mean? There's a category on eBay called used, and it's overused, and used needs a lot of explanation, but it also needs some analysis. Here are all the different useds I've seen on eBay. Used for parts only. That means everybody knows it doesn't work and they're selling it cheap. But it also means they probably know it's really broken, and it's pretty obvious from the photos it's broken. There's used and functioning, but not tested. Usually this is accompanied by selling it for a friend. Those are always very suspicious purchases. Used, under power, come and see at our facility. That usually means you're going to pay for it because somebody else thinks it's worth something and they know it still works. There's also used, see the YouTube video, which is a small guy trying to act like a big guy, showing you that it still works, but he doesn't have a huge facility to keep it powered on and serve you coffee when you go look at it. There's also newer machines that are used, and they often advertise that they're not that old, but in fact when you look at them, they may only be 5 years old, but they've been in production and they are wore out. But used and assessing the machine so you don't get a total failure on your hands is what we're trying to show you. So be careful with used, but it's also where the good stuff lies. So let's pick a pearl out of this clamshell. So what could possibly go wrong? What are the pitfalls when you're looking at this old equipment? Well, first of all, you kind of need to know what you're looking for, but here's my list of some pitfalls and things I worry about. Will it take more time and money than anticipated? Maybe. Will it work perfectly when I finally finish? Do I need specialty tooling to disassemble or adjust? Usually, the mechanical device is okay, but what about all these fancy electronics? Am I going to need parts from the original equipment manufacturer, and what if they don't exist or supply them anymore? Is the corrosion too extensive? Is a major casting broken or cracked that I couldn't see online or when I went to visit, and I only find it after I've done a lot of work on the machine? Is there a parts manual or operating manual? Either one would be a great help. What if you find the manuals, but they're in a foreign language because you chose a European or Asian machine to restore? Shipping and rigging costs can get expensive. You sure wouldn't want to buy something on the other side of the country and spend $6,000 to ship it if it's a $2,000 machine. So you got to make sure you get that one right. I would definitely put shipping and handling and rigging in there, because sometimes, most of the time with stuff like this, you'll need a forklift on both ends to load in and load out. You need to calculate this stuff and figure it out before you buy. When I look at this machine, this is pretty much the way we got it. All we've done is given a little rub down and so on. But if we come over here on this side, we see that it appears that were push buttons here for the primary functions: coolant pump, pressure oil pump, and grinding wheel. There's also a work spindle, so it looks like all the primary electrical functions were taken care of on this side of the machine. But what I see is these are covers to cover the hole back up after they've removed the switches. So somebody's changed the electronics on this, and they didn't even tighten the drawer. Luckily that didn't fall off on the freeway on the way here. This appears to be some sort of rheostat, and those look like RPMs to me. And as we come around here, this symbol here is definitely Tsugami's symbol, and this machine was actually made in Tokyo in 1952. It's called a Tug 300. I don't know what that stands for, but this is very characteristic of Tsugami. Even the brand new Tsugami equipment carries this symbology. This is our main wheel, and in general, when I look at the front dashboard of this machine, what I really liked when I first saw it was all these Bakelite handles are still on the machine. Usually, a lot of machinery gets broken or tipped over, but I mean, this one was even loose, but it's still here. So all the Bakelite handles, all the hardware looks original. The buttons look original. The little wheel dresser is up here, stored in its temporary position, but it can come down here. All these dials and knobs move. They're all free. All these have really nice positive indents and action. And usually when you get a piece of equipment, you don't really even maybe know what all the positions are, but if you can move it without a lot of force and it's acting right, then it gives you some confidence that what's going on the inside is working properly. Nice big shift here. And this is another rheostat. I'm not sure exactly what this one's for. And there's no markings. It just goes from 0 to 10, some percentage of 100, I would suppose. And there's another knob up here. This one indicates feed fast or slow. Again, it's all original equipment. Now, when we look underneath, they spell the name, and this is just beautiful. Look at this big fill jar, fill cap for the oil. And the whole base of this machine is full of hydraulic oil. Look at that thread. That's a really nice big filler cap. Super well machined. And below is the sight glass, and you can see in faint red top and bottom where it goes. There's just a little oil in it. You're supposed to transport things with very little oil or none. And then there's the drain right here. So we got the fill and the drain and the sight glass lined up beautifully. They're all right together. That's super handy for maintenance. And they're all there, and they all look original. This handle is here, and when I first got the machine, I was looking at it when I was first around it, and I thought, well, something's wrong because something's supposed to move. When you actuate this lever, it engages the system so that it'll work. Now, about one of the only things we've done in the machine so far is, in a very temporary fashion, we put this plate up here because the plate, whatever was here, was being used for something else, and it was leaking too. So we sealed this up, and you can see a big worm gear right there, and it's to reduce the drive on this DC motor to the spindle. Big gear reduction. And then this is where we get to the kind of shady stuff. Baldor makes great equipment, but here's a variable frequency drive. That's new. That's not vintage. And also, this box is full of very non-vintage stuff. All those controls that are on the other side of the machine, they're over here. And so this is definitely an add-on that somebody used to make the machine work. Also up top here, you can see these. All this hardware is complete. This whole head here can rotate. It's got the original oilers on it. Those little oilers still work just fine. That's pretty slick. And if we keep coming around the side and the back, we can see that the coolant pump is still here, and the spindle motor is complete. It did come with a grinding wheel and a plate to hold it on. And this main spindle, just like down below, if you can see right in here, there's another sight glass right here, and it allows you to see what the oil looks like in your spindle. Your main grinding wheel needs to go really fast, so this spindle is needs to be oiled properly, and there's a whole nother sight glass on the other side as well. This is one of the few things that doesn't look stock, and this is the inside diameter spindle, but it's got a great mount for it, and these are highly replaceable in a pretty standard size, so we could change this out. But this air spindle, all we did was put a new fending on it and test it, and it'll work. I'm not sure for how long, but it should work. These really nice square pegs. There's some on both sides of this table, and if you can see the markings there, not sure if the light's super conductive to it, but 0 is right there where the indicator is, and you see all along it, you see the markings. And so this entire table can swivel, and it allows you to grind in tapers. You can make Morse taper 3 tooling, Morse taper 4, so on. So you can grind those tapers very accurately with this device. So on the back, it actually has a different plug for the internal grinding wheel. This is an electrical attachment for the ID grinding wheel, but it was converted to air, so this isn't used, and I don't have any of these fittings, and it's unlikely I'll be able to match that. Again, here's where somebody has rerouted all the electricity to the other side, all the switches, and here's incoming power. They call it a terminal box. There's cavities in the machine, and you see these bolts around in different places, and these are really just drain plugs or clean out plugs or sight plugs that have on the machine. It's a pretty big, bold thread on the machine, and pretty cool looking actually. And this is one of the items that was really a indicator of some of the difficulties we were going to have. They actually have the wiring diagram on the back. It's really clever. It's really well done. It's clear. But it started telling me I'm going to have some issues with electricity on this thing. But for the most part, down in the base, there's a big motor down there that runs a hydraulic pump. It's a regular induction motor. The spindle motor up top here, underneath this big, beautiful curved case. It's a belt-driven main spindle. It's heavy. This is an induction motor. So a pretty standard 3-phase induction motor that is relatively easy to wire. You can see in the ways here how the fluid can come around here and then drain into this big pan. And this pan is all closed and the coolant pump comes out. Now this motor is the one that's going to be different. It says right on the plate it's a DC motor, direct current motor. That's pretty non-standard, if you will, for most of the machine tools I work with. Most are 3-phase or single phase, but not direct current. They're almost all alternating current. And it also says the word shunt on it, S-H-U-N-T. So how am I going to get that thing to work? It's hooked up to a Baldor variable frequency drive. We'll have to just see how that works, see if we're going to replace it or just use it. But kind of the crown jewel of this machine and of all grinding machines is how well can you get it to come into tolerance and how well can it measure. As you can tell here, we've got a Noga on it, and this entire back spindle is what moves back and forth. So if you can look at the indicator here, I'm going to see if I can very gradually move it over just a little bit. So this indicator reads to 5/10,000ths, so each division is 5/10. And this button right here, the 10ths button, every time I push it, it goes 0.0001 inches. It moves the wheel, and it moves the indicator, and it moves this entire motor assembly with the push of the button 1/10,000ths. So this particular machine, we have a few pitfall problems, but why did we choose a Tsugami? Well, when we filtered out all the pros and cons and our need and our timing, we found this locally. We learned about Tsugami. They're still in business, Japanese. They still sell brand new machine tools in the US. We're going to have to probably go back to Japan to get information on this one, but the company, their whole meaning in machine tools, their philosophy of design is to always design a super heavy casting, overbuilt casting, so that it has just excellent rigidity problems, which means you're going to be able to have parts that you can repeat the same process on, and they're going to be the same. So I really like that as a machinist. That concept of rigidity can't be understated. You know, you don't want a machine that's wobbly or can't hold tolerance. So this thing is built all about the casting. It's almost 5,000 pounds of dense steel casting, and all the parts have just huge way surfaces on them to be able to reliably make their machining moves from all the way from here to the main spindle ways to the ways underneath here on the machine, and just the density of the machine itself. It was close by, it was super well built, and I would call this, when you find a machine like this, I would call it a generational machine. It's already served for 70 years. Maybe not all of that, but it's been around for 70 for sure, since 52. It's probably got another 50 or 60 or 70 years in it. There's nothing on this machine that is not replaceable fairly easily that you can't redo. That's why we chose it. Now, these machines are simple to operate, and really if you start taking them apart, they're pretty easy to repair too. This is how you put parts on and off the machine, and this holds a collet in on the other end. So there's your workpiece right here that goes in this collet. It's a 5C collet machine, so it's very universal. It fits with all our other 5C tooling we have in the shop. This big spindle here that turns your workpiece, it needs to be very rigid so it doesn't wobble. It doesn't go especially fast, but it needs to be very stable. There's huge bronze bearings or brass bearings, I'm not sure which, on both sides of this thing. They've got huge oiling galleys in them for these oilers to drip into, and it's highly adjustable. So it had just the slightest amount of wear in it, and I was able to take them out, snug them up, and get them to fit just right into the spindle so that there was no run out on that main spindle. That can be done to this machine probably 10 or 15 more times, and it looked like to me I was the first guy in there messing with that stuff. So it really fits that identity as being a generational machine, multi-generational machine, and that fits right back on. So those are some of the easy, that's a little bit of the easy work we did to this much more complicated part here. The machine in general is actually made, if you get Machinery's Handbook, great resource, go get it, and look at all the machinery components that are out there, bearings and shafts and seals and spindles and collets and etc., etc., etc. Machines are just composed of all those simple elements. So when Tsugami designed this, it may be pretty cool and complicated the way they designed it, but on their factory floor they wanted to make a bunch of them, and they wanted to have them relatively easy to put together. The easier they are to assemble, the less they spend on labor, the more they can make on the machine. So this machine has a lot of basic elemental parts in it, machine concepts, and that also, what I found in most older equipment, that falls right in line with that it's going to be relatively easy to repair and take apart. Once you know these basic elements, how bearings and seals and shafts and keyways and pins and all the other basic elements that are in here, gears, bevel gears, worm gears, electric motors, motors that go fast, motors that go small, belts, they're all very basic machinery concepts. Now there's something about old machinery you just need to get over. It might sometimes have rust on it. We wipe most of the outer layer of crust on this off, which I like to usually leave because it's usually protective. But rust is not a terrible thing as long as it hasn't attacked some of the main working way surfaces. Some of these things just look bad. Grinders are a notoriously dirty machine. That just looks bad, just didn't get cleaned off. It'll clean off just fine. So, just because some of its chrome might be gone or worn, it's kind of an indication of the life it's lived, so it's part of its patina. How it looks doesn't matter nearly as much as how it machines. It's a lot like people. It's what inside that really counts. Now, the other thing about this machine that's great is who wouldn't want to work on it? I mean, look at these curves. I mean, they have the curved dome on this motor is just beautiful. The logo's awesome. Just the ergonomics of this, I wish I knew what went there. And then on both sides, it's got these beautiful vents to vent the air out when the motors are running. And it's got these panels on these three back sides. Not to mention the big curved hood that goes over the main spindle induction motor. And you know, this is a good looking machine. I will be really proud to finally fix it and move it in the shop. And if that wasn't enough, it came with a diamond right there. So one of the better ways to get some education on this, since this is not necessarily taught in school, the crash course on used equipment might go get a lot of perspective from eBay, read a lot of people's websites, go look at your used machinery dealers in your area.